Hello and welcome to the session. In this session, we will discuss variance and standard deviation. Variance is basically mean of the squares of the deviations from mean. It is denoted by sigma square and its formula is given by sigma square equal to 1 upon n summation I goes from 1 to n xi minus x bar the whole square, and standard deviation is given by sigma, and this is equal to square root of the variance, that is square root of 1 upon n summation I goes from 1 to n xi minus x bar the whole square, where xi are the observations, x bar is the mean, n is the total number of observations, these formula are basically used for the ungrouped data. Consider this data given to us where n is equal to 10 and mean, that is the x bar is equal to summation xi upon n, which comes out to be equal to 12. We have found out the values for xi minus x bar. We get these values. Now we find out xi minus x bar the whole square, which is equal to 9, 25, 4, 1, 25, 36, 9, 36, 4, 1. Now the variance sigma square is equal to 1 upon n, that is 1 upon 10 into summation xi minus x bar the whole square, that is sum of these values, which is 150. So 150 upon 10 is equal to 15. This is the variance. Now the standard deviation sigma is equal to square root of 15, which is equal to 3.872. So this is how we calculate the variance and standard deviation for ungrouped data. Next we will discuss how we find the variance and standard deviation for discrete frequency distribution, that is for group data in the form of discrete frequency distribution. Here variance sigma square is given by 1 upon n summation I goes from 1 to n fi into xi minus x bar the whole square, and the standard deviation sigma is equal to square root 1 upon n summation I goes from 1 to n fi into xi minus x bar the whole square. Suppose that this is the discrete frequency distribution given to us, in which we are given the observations xi and the corresponding frequencies fi. Now here we have n is equal to summation fi, that is equal to 20, that is sum of these frequencies. Then the mean x bar is equal to summation fi xi upon n, that is equal to 360 upon n, that is 20, which is equal to 18. That is the mean x bar is equal to 18. Now the values xi minus x bar, we have minus 8, minus 3, 0, 2, 7. Xi minus x bar the whole square, the values are 64, 9, 0, 4, 49. Then fi into xi minus x bar the whole square, we get the values 192, 18, 0, 32, 98. The variance sigma square is equal to 1 upon n, that is 1 upon 20 multiplied by summation fi into xi minus x bar the whole square, that is sum of these values, which is 340. So sigma square, that is the variance, is equal to 17. Then the standard deviation sigma is equal to square root of the variance, that is 17, which is equal to 4.123. Next we have variance and standard deviation for continuous frequency distribution. The given continuous frequency distribution can be represented as a discrete frequency distribution by replacing each class by its midpoint, and the variance and the standard deviation are calculated by the technique adopted in the case of a discrete frequency distribution by using the formulae given by sigma square, that is the variance equal to 1 upon n summation I goes from 1 to n fi into xi minus x bar the whole square, and the standard deviation sigma equal to square root of 1 upon n summation I goes from 1 to n fi into xi minus x bar the whole square. Now we shall discuss another formula for calculating the standard deviation and the variance for given data. We are given variance sigma square is equal to 1 upon n square multiplied by n into summation I goes from 1 to n fi into xi square minus summation I goes from 1 to n fi into xi the whole square, and the standard deviation sigma is equal to 1 upon n into square root of n into summation I goes from 1 to n fi into xi square minus summation I goes from 1 to n fi into xi the whole square, where again n is equal to summation fi, that is sum of the frequencies, xi are the observations, fi are the corresponding frequencies, then n is the total number of observations, suppose this is the data given to us in which we are given xi and the corresponding frequencies fi. Now xi fi given by 30, 30, 90, 160, 50. Now xi square is given by 100, 225, 324, 400 and 625. Then fi into xi square is given by 300, 450, 1620, then 3200 and 1250. Now here we have n is equal to summation fi, that is sum of the frequencies, which is equal to 20, then summation fi into xi square is equal to 6820, then we have summation fi into xi would be equal to 360. Now variance sigma square is equal to 1 upon n square multiplied by n into summation fi into xi square minus summation fi into xi the whole square. This comes out to be equal to 17. Then standard deviation sigma is equal to square root 17, which is equal to 4.123. This is the standard deviation. Next we discuss the shortcut method to find the variance and standard deviation. By the shortcut method, the variance sigma square is given by h square upon n square multiplied by n multiplied by summation fi into yi square, where I goes from 1 to n minus summation I goes from 1 to n fi into yi the whole square, and the standard deviation sigma is equal to h upon n into square root of n into summation I goes from 1 to n fi into yi square minus summation fi into yi I goes from 1 to n the whole square. Here we have the step deviations yi is given by xi minus a upon h, where this a is the assumed mean, h is the width of class intervals given, n is the sum of the frequencies, that is summation fi. Fi are the frequencies. Consider this data given to us in which we are given the class intervals and the corresponding frequencies fi. Now here xi is the midpoint of the class intervals given by this. Now here h, that is the width of the class interval, is 30. Now we take assumed mean a to be 105. So a is equal to 105. Now we have yi is equal to xi minus a, that is the assumed mean, upon h. So the values for yi are given by minus 3, minus 2, minus 1, 0, 1, 2, 3. Yi square is given by 9, 4, 1, 0, 1, 4, 9. Now yi into fi is given by minus 6, minus 6, minus 5, 0, 3, 10, 6. Now yi square into fi is given by 18, 12, 5, 0, 3, 20, 18. Here we have n equal to summation fi, that is sum of the frequencies, and that comes out to be equal to 30. Then summation fi into yi is equal to 2. Then summation fi into yi square is equal to 76. Now the variance sigma square is equal to h square upon n square multiplied by n into summation fi square minus summation fi the whole square. This comes out to be equal to 2276. Now the standard deviation sigma is equal to square root of the variance, that is 2276, and that comes out to be equal to 47.71. So this is the shortcut method to find the variance and standard deviation. Next we shall discuss coefficient of variation. Whenever we want to compare the variability of two series with same mean, which are measured in different units, we do not calculate the measures of dispersion, but we require such measures which are independent of the units. So, the measure of variability which is independent of units is called coefficient of variation, denoted by CV. Coefficient of variation CV is equal to sigma upon x bar multiplied by 100, where x bar is not equal to 0. Sigma is the standard deviation and x bar is the mean of the data. For comparing the variability or dispersion of two series, we calculate the coefficient of variance for each series. And the series with greater CV, that is greater coefficient of variation, is said to be more variable than the other. and the series with lesser CV, that is lesser coefficient of variation, is said to be more consistent than the other. If we have two series with equal means, then the series with greater standard deviation is called more variable, or you can say more dispersed than the other, and the series with lesser standard deviation or variance is said to be more consistent than the other. Like suppose we are given mean x bar equal to 3500 for two distributions and variance for first distribution given by sigma 1 square is equal to 64 and variance for the second distribution given by sigma 2 square is equal to 81. So from here we have standard deviation given by sigma 1 for the first distribution is equal to 8 and sigma 2, that is the standard deviation for the second distribution, is equal to 9. Coefficient of variation CV1 for the first distribution is given by sigma 1 upon x bar into 100. This is equal to 0.228. Then CV2, that is coefficient of variation for the second distribution, is equal to sigma 2 upon x bar multiplied by 100, which comes out to be equal to 0.257. As you can see, coefficient of variation for the second distribution is more than the coefficient of variation for the first distribution. So we say that the second distribution is more variable than the first. So this is how we find the coefficient of variation. This completes the session. Hope you have understood the concept of variance and standard deviation and coefficient of variation.